All right, so in the 1940s, a couple of scientists named Michelson and Morley uh, discovered some interesting things about the atom and its behavior, how it functions. So they did an experiment where they used a kind of machine to fire atoms at a screen, and before the atoms hit the screen, they had little slitted barriers that the atoms had to pass through. So, what they discovered is that when the atoms pass through, when being observed, they would make perfect little little patterns. But okay, so that's what they first observed. But when they weren't looking at the measuring mechanism, when they were turning their backs on it or whatever, the atoms acted in a different way. So when the atoms went through the slits, they made a different pattern entirely. And they acted not like little bullets, but they traveled more in waves. Like so. Alright, so that brings us directly to Schrodinger's cat. Alright, so Schrodinger was a philosopher back a long time ago who studied wave function, and he demonstrated wave function with this thought experiment using a box a cat and some poison. Now, what he said was that if we is it still going? Okay, if we put a cat in a box and give it some poison, it's going to die. But if we're not looking at the cat, does it still die? I have no idea. More? Okay. So, now that we understand that, we're going to move on to the whole point of this lecture, the Copenhagen interpretation. So, the Copenhagen interpretation, created by Niels Bohr and some other scientists, Einstein, Vernier, Pauli, and Schrodinger was in on this too. Wiener Heisenberg. They wanted to try to explain the experiment that Michelson and Morley had done, the double slit experiment. They wanted to explain the behavior of the atom, have it make sense. Okay, so they proposed that measuring, the simple act of measuring the atom affects its behavior. So that's it, really.
Drive atom. And then a ruler.
Atom. Okay, so by observing the atom, by measuring it, it changes its behavior entirely, from having a kind of striped pattern to a wave pattern of behavior. So that explains why an atom can be in two places at the same time. And the other interpretation, the other worlds interpretation, the many worlds interpretation states that atoms, they just act, there's no rhyme or reason to the way they act. They can be here, and 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 they're the same things, but they're all over the place, but they're the same. Alternate universes. The end. Thank you. I hope you enjoyed this lecture.